There's a new tool being developed to help farmers and agronomists get a plant's eye view. Robodogs.
There's a gap, as it were, for an extra imaging platform in the field or in the glasshouse. There's satellites, there's drones, there's phones. So it's basically integrating the dog into this matrix of imaging platforms. It can get high-resolution imagery from the field or the glasshouse. Different viewing angles in the drones. It can view from the side to actually see, pests and diseases within the crop. Unlike a rover with tractor or wheels, it's not going to squash the crop, so it can operate on much boggier, wetter soils as well to get around. It's very good on rugged ground. This spinning thing here you can see is called the LiDAR, and there's got one on its back as well. This is a bit like driverless car technology to sense in 3D the area around it. The camera's on the front here. This is a standard RGB plus a depth camera and take images. But importantly, we've got a graphical processing unit or a GPU in it, and this enables to run our computer vision models for things like spotting, crops versus weeds. 3 to 4 hour endurance, which is, far greater than a drone. And also its feet are rather special on this dog. It can actually sense when it touches the ground, enabling this robot to actually run at about 18 kilometers per hour. One of the things we realised quickly, the dog is quite bouncy when it walks along. We need to stabilise the camera. So we've used some technology from Hollywood here. So they use these in car chase scenes. This is a mechanised stabiliser for the camera. And then we wanted to improve the camera quality as well. So we put on high definition cameras to really capture the quality of crop in exquisite detail. But you can also see using its LiDAR to see the world in 3 dimensions. Comes with its own self-charging mat, so it can walk onto the mat, find it itself, sit down, and it will fully charge for you.
And that'll obviously help as well with the automation part of it, making it not need human intervention.
So it can run 24/7.
At the moment we've got the camera set up so it's pointing perpendicular to the dog itself.
The dog can walk up and down the rows and we'll be capturing the images alongside. So the way we're doing this at the moment is we're filming a video, then take those frames and we can use those to create a 3D environment, which will give us a lot of that 3D detail about the plants. The biggest problem with it is that if I run it up and down here and then I do it again, those 2 videos aren't going to be the same. There's going to be some differences there, just naturally caused by the fact that it's a human controlling it. Whereas the point of automation is that level of precision that humans just aren't capable of.
Yeah.
We can actually start sort of testing how much can we allow the dog to go out by itself and do all of its analysis. How much do we want a human to have it, for example, one human directing a number of dogs. It's really exciting working in this space. This is just things that weren't possible even a few years ago. So seeing how it's used at a company like Syngenta where they're using it for such forward-thinking research.
So longer term, there's 2 ways this could go. First route is to help R&D processes in Syngenta. So this could be in the glasshouse for vegetable seed production, so the dog can help assess yield. The other approach is for crop protection development, so out in the field, we could get the dogs helping with the assessment of trials, again counting weeds, looking for pests, looking for diseases. So I was in the early days of drones, and look where they are now. So give it 5 or 10 years and it'll probably be unrecognisable, so it's good to get in at the start.